Hey guys, today we're going to be starting the first lesson of Math 9. This lesson is focusing on just different types of rational numbers. Nothing from this lesson should be new to you guys. This is all stuff that you would have done probably for the last couple of years. In fact, most of the stuff that we're going to be doing in chapter 1 will be stuff that you did in junior high, and we're just kind of reviewing it all. But in case you don't remember, let's go over a little bit of review. Okay, so this is lesson 1.1, rational numbers. And so we'll start with just a couple definitions. So a rational number is any number that terminates or repeats. So what we mean by that is any number that either ends or where you have the same number repeating itself until the end of your calculator, where usually it rounds it for you. So that could include examples like 4.76 because it ends or terminates. Or it could be something like 2.33333333 because that is a repeating number. Rational numbers can be decimals, like what I just gave you examples of. They can be fractions, like 1/4 or 2/3. They could be mixed numbers, or they could be integers. So they can be both positive and negative. A natural number are all whole numbers above 0. So 1, 2, 3, 4, 5, so on, so on. A whole number is all of those numbers that I just listed, including 0. So the only difference between a natural number and a whole number is that a natural number doesn't include 0 and whole numbers do. An integer is a positive or negative whole number. A decimal is anytime you have a decimal after your whole number. Fractions can be both proper and improper. Sometimes you might hear a fraction referred to as a quotient of two integers. That's just a number divided by another number written as a fraction. And then obviously a mixed number is when you've got the integer in the front and then the fraction afterwards. So what we're going to be mostly focusing on for this lesson is how to convert between different types of rational numbers. So we'll start by converting between decimals and fractions. So if we're starting off with a decimal and we want to turn it into a decimal, the first thing that you want to know is some of these terminologies here. So the first place after the decimal is the tenth, the next one is the hundredth, the next one is the thousandth. What we're going to do is we're going to write this decimal as a whole number in the numerator position. Then we're going to write the corresponding decimal place of the last part of our decimal number in the denominator position, and then reduce the fraction to lowest terms. So let's go over a couple examples of what that would look like, and make sure you copy these examples down. Okay, so let's start with the decimal 0.25. If I want to turn this into a fraction, you might just know what 0.25 is as a fraction, and if so, great, write it out. But if you don't, we're going to start by taking the 0.25 and we are going to write it as just 25. So we're going to get rid of the decimal itself. And then we're going to write that in the numerator position of the fraction, so the top of our fraction. Then what we'll do is for the denominator position, that is based on the place of our last number of this decimal. So the 5 is in the 100th position. And so I'm going to write this as 25 over 100. And then to put this in lowest terms, all we're going to do is say, okay, well, what can both of these numbers be divided by? What's the biggest number they can both be divided by? And you might not know right away. You might not know that these are both divisible by 25. And if instead you say, well, I think I can divide them both by 5, Well, then start by doing that. Start by saying, okay, I can divide that by 5 and I can divide that by 5. 25 divided by 5 is 5. And then 100 divided by 5 is 20. And now that we've got a smaller fraction, it might be easier for you to say, oh, I know that 20 is divisible by 5. So now I can divide both of these by 5 again, and that's how we get 1/4. Now, many of you will already know that 0.25 is 1/4. But you might sometimes have more complex decimals than that. So that is how you would use this process. Okay, so take your number, write it as the numerator without the decimal. Because this was in the 100th position, and sorry, my writing's terrible, that's why we wrote 100 here. Okay, let's try it again if I have something like 0.6. This time, I can write my number 6 on the top, because again, I'm just ignoring the decimal. And the bottom this time isn't going to be 100 because this only goes to the 10th position. So it's just going to be over 10. And then once again, I'm just going to put 6 over 10 into lowest terms. So both of those are divisible by 2. They're both even numbers. And if I divide 6 by 2, I get 3. 10 by 2 is 5. So 3/5 would be your answer. Okay, let's go on to going in the opposite direction. So going from a fraction to a decimal. Now, if you had a calculator, all you would do is take the top number and divide it by the bottom number in your calculator, and that would give you the decimal. But on your PAT, there is a no calculator section, and you have to know how to divide these numbers without using a calculator. So let's go through how to do that. So let's just see if we can work through this one backwards. Let's say I started with 3/5 and I needed to turn that into a decimal. What I'm going to do is I'm going to say, okay, my 3 is being divided by the 5. And so we'll say, how many times does 5 go into 3? And the answer is, of course, 0 times. 5 cannot go into 3. So we'll put a 0 there, and then I'll put a decimal right here, both on the top and behind the 3. That allows me to add an extra 0 here, so 3.0. Now I'm going to say, okay, how many times does 5 go into 30? And I'm going to ignore the fact that there's a decimal here. Well, 5 can go into 30 6 times. 5 times 6 is 30. And when I subtract those, there is 0 remaining. So my final answer is just 0.6. Let's try one that's maybe a little more complicated than that. What if I start with the fraction 2/3? And again, I'm giving you fractions that some of you might just know what they are in decimal form, but you still want to be able to go through this process for if you're given more complex fractions. So this time I have 2, which is being divided by 3. So we set it up like this. Once again, 3 can go into 2 0 times. So I'll put my decimals in and add a 0. Now I'm going to say 3 can go into 20. How many times? And the answer is 6 times, because 3 times 6 is 18. And then we subtract those, and my remainder is 2. So I'm going to write another 0 and bring that down. Now I'm going to say, how many times does 3 go into 20? And of course, once again, it is 6. Because 3 times 6 is 18, and if I subtract them, I get a remainder of 2. And as you can see, in this case, I just keep having to divide 3 into the same number, into 20, which tells me that I've got a repeating decimal. So I could write this as 2/3 is equal to 0.6 repeating. Okay? So as soon as you see the same number over and over again, that's how you know you have a repeating number that you're dealing with. Okay, next we're going to go between a fraction and a mixed number. So in this case, your fraction is going to be an improper fraction. So for example, I might have like 23 over 5. Okay, an improper fraction, just as a reminder, is a fraction where the numerator is bigger than the denominator. So to convert this to a mixed number, I'm just going to say, how many times can 5 go into 23? And 5 can go into 23 4 times. I know that because 5 times 4 is 20. So if you need to kind of write that in somewhere else, 5 times 4 is 20. Now I want to know how much is left over. And so because 5 times 4 is 20 and I'm trying to get to 23, I have 3 left over because I'm just doing 23 minus 20. Is that 3? And then I keep the denominator. So keep the denominator of 5. Okay, that's all you do for that one. If I'm going the other direction, if I'm doing, let's say 4 3/5, and I want to turn that into a fraction, all I'm going to do is I'm going to take the denominator, so in this case the 5, and multiply it by the whole number, so the 4, and then add the numerator. So 4 times 5 is 20, plus 3 is 23. That is how I get my numerator, and then I just keep the denominator. The one thing that is important to note is if my mixed number is negative, so let's say I had like -2 and 2/3. When I am doing this multiplication and adding, I ignore my negative sign. So I'm going to do 3 times 2 is 6, plus 2 is 8, and keep my 3. If you actually used that minus sign, you would have done 3 times 2 is -6, plus 2 is -4, and you would have got -4 over 3 here instead. Now we have 8 over 3, and all we have to do is put that negative sign back in again. Okay, so make sure you ignore the negative sign and just stick it back in at the end. Okay, the last ones that we're going to do is converting between decimals and mixed numbers. So let's say I had 2.3 as my decimal. What I'm going to do is I'm going to keep the whole number, so in this case the 2, and then the decimal part I'm going to convert into a fraction. And again, all we do to do that is take the decimal portion, so in this case 3, and put it over whatever place it's in. So in this case, it's in the 10th position, so it's 3 over 10. If we had something like -5.5, to 5. Then I would keep the -5. And the 0.25, I would, of course, write as 25 over, in this case, 100, because again, it goes to the 100th position. And then I would put my 25 over 100 into lowest terms. Just as a bit of a heads up, on a test or quiz, your fractions must always be in lowest terms. If they're not, you won't get full marks for them. Okay, if you're going the other direction, so if you start with, say, 2 3/10 and need to get a decimal, you're going to keep the whole number. And then for the decimal portion, you're going to divide that out. Or sorry, for the fraction portion, to get the decimal portion, you have to divide it out. So in this case, you're going to say 3 is being divided by 10. How many times does 10 go into 3? Well, it doesn't go in at all. So I'll put in my decimals in my 0. How many times does 10 go into 30? 3 times. Because 10 times 3 is 30, and if I subtract them, I have none remaining. So that's how I get 2.3. Okay, that is it for today's lesson. I know this seems pretty easy, and it's definitely super straightforward if you do it in a calculator. On the tests and quizzes, you will be given a calculator, but this is something you'll have to know how to do without a calculator for the PAT.